Okay, so this is going to be our third and final video of day 5 of Unit 4 for Algebra 2. And in it, we are going to obviously discuss how to solve logarithmic equations. Now, real quick, before we get started, I want to go ahead and point something out about logarithmic equations. Logarithmic equations, can have uh, extraneous solutions. Okay, so that's a fancy way of saying that we can have solutions for logarithmic equations that don't work when we go back and plug them in. Okay, and this is because logarithmic functions. I'm just going to say log functions have domain restrictions. Okay, so they can have extraneous solutions because log functions have domain restrictions. So, for example, if I had log base, who cares, 2 of x minus 3, let's say, right, is equal to f of x. Okay, well, of course, we have to consider that x cannot be just anything, right? So I'm shifted to the right by 3, which means my vertical asymptote exists right here at x equals 3. Okay, so what that means is x needs to be greater than 3. Okay, otherwise, right, our solution there would be extraneous. Okay, so because we have domain restrictions, right, our domain would go from positive 3 to positive infinity. Because we have those domain restrictions, that means we can have, we call it extraneous solutions. So let's look at this first example. Okay, so two schools of thought here. Uh, so obviously, I can rewrite this as an exponential function. So I can say 3 to the fourth power, whoops, 3 to the fourth power is equal to what's here inside the parentheses. So 3 to the fourth power is equal to 4x plus 1, right? The other train of thought here would be, let me rewrite this. So log base 3 of 4x plus 1 is equal to 4. The other train of thought here is that I'm going to do the inverse of log base 3. So that's exponential base 3. And what I do to one side, I do to the other, right? So exponential base 3, log base 3 cancel their inverses, right? And that gets me to 4x plus 1 is equal to 3 to the fourth power, right? So we see we get the exact same thing either way we do it, okay? So I'm going to go ahead and follow up from here. So I'm just going to subtract 1 from both sides. Oh, and 3 to the fourth power is 81, by the way. Okay, so 3 to the fourth power is 81, because that's 3 times 3 times 3 times 3. That would be 81. I'm going to subtract 1 from both sides, right? And now I've got, I don't know why I wrote that stuff out. Now I've got 80 equals 4x divided by 4, and obviously x is going to be equal to 20. Okay? And again, I can check my work just to make sure, that this solution actually works, right? So based on what I said here in green, I'm going to go ahead and do that. So if I said log base 3 of 4 times x plus 1 is equal to 4, okay? 4 times 20 is 80, plus 1 is 81. So I have log base 3 of 81. And we, of course, know that that is, in fact, equal to 4, right? All we need is a calculator to prove that, okay? So next example, okay, and I'm going to go ahead and boot up my calculator while I'm working this. Okay, so this next example, number 2. So this one is a little bit gnarly. You'll see why here in a second, but it's really not that bad. Okay, it's just your first time maybe seeing something like this. So I've got natural log. Cool, yeah, just put it right in front where I'm trying to do something. Oh, great. What a great way to ruin my video. Thank you, Texas Instruments. Okay, anyway, so I've got natural log here, natural log here. They both match, right? So because of this minus, I can go ahead and utilize the quotient law of logarithms. So that means I can rewrite these two guys as a single logarithm, ln of x plus 4 all divided by x minus 4 is equal to 4. Okay? So you can use the arrows like I did up here in this last example, or you can use straightforward robot algebra. I don't care which one you do. But either way, because this is natural log, right? We know that means log base e, or Euler's number, right? Euler's number, whatever. Okay, so that means I'm going to have e to the fourth power is equal to x plus 4 over x minus 4. Okay, now we're going to use our little trick if we remember from geometry. Put e to the fourth power over 1. Okay, so cross multiply, right? So that means e to the fourth times x minus 4. E to the fourth times x minus 4 is equal to x plus 4 times 1, which is just x plus 4, of course, right? Now I'm going to go ahead and distribute here to here. So that gives me e to the fourth power times x minus 4 times e to the fourth power is equal to x plus 4 still, right? Come back over here. Okay, so what I want to do now is get the x's on one side and the constants on the other side. Okay, so what we're going to go ahead and do, I'm just going to do minus x on this side, right? And I'm going to do plus 4e to the fourth on this side. And of course, what I do to one side, I have to do to the other, and vice versa, right? So then that means these two will cancel. So I'm going to have e to the fourth power times x. These two will cancel. And again, what I do to one side, I do the other. So that minus x comes over here. The 4 stays over there. And then we, of course, have this plus 4e to the fourth that I have to account for on the other side. Okay? Now, this is where it gets a little bit goofy. Okay, so this is where we're going to need our calculator, right? So let's see if I can fit this here in the window a little bit better than this. You know what? I'm going to change the view on this. That's not what I was looking for. Here we go. We're just going to say handheld only. There. That's a lot more user friendly, kind of. Okay, anyway. So if you remember, right, Euler's number is about 2.72, right? So imagine for a second if we had 3x minus x. Well, duh, that's 3x, take away 1x, that's just 2x, right? So this is not any different than what you see right here. Okay, so 2.72 to the fourth power of x minus 1x. So we need to find what is e to the fourth power minus 1. Okay, that right there is going to be what we're going to enter into the calculator. So I'm going to say e to the fourth power. Maybe I'm not. I'm going to say e to the fourth power, all of that minus 1. Okay, that is going to give me about 53.60. So then that means this right here, these two are like terms that combine into about 53.60x, which is of course equal to 4 plus 4 times e to the fourth power. Okay, now it's as simple as dividing both sides by 53.60. And I shouldn't say approximately, it's going to be exact. Okay, and then that, of course, we're going to also chuck in the calculator. So I'm going to hit Control Divide. I'm going to go ahead and do 4 plus 4 e to the fourth power. All of that divided, of course, by, so I'm going to hit Control C to copy, Control V to paste it. Okay, and I get that x is about 4.15. Okay, and if I go ahead and plug this back in, okay, just to make sure that it works. So I'm going to say natural log of x, go ahead and copy that, plus 4 minus natural log of x minus 4. Okay, and then that should be equal to 4, and that's exactly what we get. We get 3.999999, incredibly close to 4. Okay, so we know that that's not an extraneous solution. We know it works, right? So obviously I'm going to have to erase some of this. So that one's gnarly, but only because of what we had to do with E. Okay, so when you get better and better at math, like stuff like that isn't really going to bother you. I'm just going to write the solution here in green. So x was about 4.15. Okay, so now we go on to number 3. Okay, and we see something similar. We have log base 2, log base 2. They match. This plus sign means we can utilize the product law. So I can combine these two into a single logarithm, namely log base 2 of 2x being multiplied by x minus 3 is equal to 3. Of course, I can distribute this 2x into here. So now I've got log base 2 of 2x squared minus 6x is equal to 3. Okay, and again, I don't care if you use the arrows like this earlier example, or if you use the straight up logical algebra there. Okay, when you do that, we're going to end up with 8 is equal to 2x squared minus 6x. Okay, so now it's just a simple quadratic. I want it to be in standard form, right? So I'm going to subtract 8 from both sides so that this 8 turns into a 0. So now I've simply got 2x squared minus 6x minus 8 equals 0. We see that all of these 2, 6, 8 are divisible by 2, so I'm going to reduce. So I'm going to say x squared minus 3x minus 4 is equal to 0. We know that this is factorable because negative 4 has factors such that they will combine into negative 3. And because a here is 1, right, we know that we can just fill in the blank. So x minus 4 times x plus 1 is going to be my two factors there, which means x is going to be equal to 4 and negative 1. So those would be my two solutions there, but we still have to check and make sure, do we have an extraneous solution, right? So I'm going to go ahead and check that right now. So log of 2 times x, so I'm going to start with the positive 4, plus log base 2 of x minus 3 is equal to 0, right? So log, I forgot to put the 2, log base 2 of 8 is going to be 3, right? Log base 2 of 1 is going to be 0, and 3 plus 0, I don't know why I put a 0 there, right? That should be a 3 because, equals 3 equals 3. So 3 plus 0 obviously equals 3. So the 4 checks out. Now we need to check the negative 1. And I can already tell you the negative 1 is going to be extraneous. So I'm just going to erase carefully here. Okay, so I'm going to replace the x's with negative 1s. Okay, so now we see that this isn't going to quite work out very well. Okay, so log base 2 of negative 2. So I have log base 2 of negative 2 plus log base 2 of, right here, we're going to have negative 4. And that is supposed to be equal to 3, right? The problem is this right here is impossible. There's no exponent that I can raise 2 to that'll give me a negative 2, much less a 0, right? And there's no exponent that I can raise 2 to give me a negative 4. That's ridiculous. So this guy right here, the negative 1, is the extraneous solution. Okay? So you have to be careful of that. Okay, so that does it for this video. Like always, if you have any questions over how to solve logarithmic equations, you know where to find me. Otherwise, shoot me an email. Goodbye.